morning, everyone. My name is Ghaziabad. I'm the assistant professor in Department of Computer Science in ABES Engineering College. And today's my topic is Ackermann function. Basically, this topic comes under data structure domain in Stack. So the content that I will follow in today's topics are what are the Ackermann function? I will explain Ackermann function with an example, some interesting facts regarding Ackermann function, and a C program for Ackermann function. So, what is Ackermann function? According to my slide, the Ackermann function takes two non-negative integers, usually denoted by m and n, small n and small n, as an input, and produces an output that is also a non-negative integer. So this is an important fact. First of all, you have to take two non-negative integers as an input. Suppose this is a function a m comma n is the Ackermann function. Okay, so m and n are arguments, and there are different conditions, and on those conditions they will provide different outputs. They will provide different outputs. First of all, this is a recursive function. Okay, this comes under recursion. What is recursion? A recursion is a process in which a function call itself again and again and again. Okay, so in Ackermann function, you will provide m and n, small m and small n, as an input. Okay, and that will give different outputs according to the conditions. So what are the conditions in Ackermann function? Suppose the value of m means the first argument. If the value of m is 0, then that function will provide output as n plus 1. Means the second argument will increase by 1. In the similar manner, in the second condition, if the value of m is greater than 0, okay, but the value of n is 0, then a m comma n will provide a m minus 1 comma 1. That means again a function. That's why I was saying it is a recursive function. And in similar manner, in the third condition, if the value of both arguments, that is m and n, in both arguments the value is not 0, means greater than 0. First of all, this is a non-negative integer. Okay, so it can't be less than 0. And in both cases, if the value is greater than 0, then the function will result in as an output as a m minus 1 comma a m comma n minus 1. Well, these are the three conditions for the Ackermann function. Now, let us take an example that will explain this function in better manner. Suppose this is the question. Apply Ackermann function for the given function a comma a 1 comma 2. 1 comma 2. Now, a 1 comma 2, that means the value of small m is greater than 0 and the value of n is greater than 0. Value of m and n is greater than 0 means third condition. So what it is giving? It is given a m minus 1 comma a m comma n minus 1. So in the similar manner, a m minus 1, that means 1 minus 1, that is 0, comma a m comma n minus 1, that means 2 minus 1, 1. It is following the third case. It is following the third case. Okay, now again, this is our resultant. Now we have to compute this function. This is a 1 comma 1. Now again, the value of a small m is 1, that means greater than 0, and the value of small n is greater than 0, that is 1. So again, it will follow the third condition, and the third condition will say that m minus 1, that is 1 minus 1, that is 0, and comma a m comma n minus 1. Look at this. This is the third condition. A m minus 1 comma a m comma n minus 1. If the value of m is greater than 0 and the value of n is greater than 0, so this will result, this will give you a result like this. So the value of a1 comma 1 is this, and again now we can see in the result we'll have again a function that is a1 comma 0, but this time we have different kind of inputs. That m is greater than 0, but the value of n is 0. So it will follow the second condition. That is, m is greater than 0, but the value of n is 0. So it will give result like this. A m comma n is equals to a m minus 1 comma 1. Now see, 1 comma 0. It will provide you a m minus 1, that means 1 minus 1, and the second argument is 1. Look at this. It is following the second condition now. So second condition is saying a m minus 1. So 1 minus 1 is 0. And n, the value of n is 1. So that's why here the resultant of a 1 comma 0, 1 comma 0 will provide you answer a 0 comma 1. Now again, like in this and these three functions, we are having different resultant. In the similar manner, we have compute a 0 comma 1. Now you can see that the value of m is 0, but the value of n is greater than 0. Now it will follow the first one, the first condition. The value of m is 0, but n is not 0. Then the value of m comma n will give you n plus 1. N plus 1. Now you can see the value of m is 0 and n is, so if the whole function will result in n plus 1 means 1 plus 1. 1 plus 1, that is 2. That's why this whole function will convert into a 0 comma. This function will give you result 2. Function will give you result as a 2. That's why a 0 comma 2. And again, you can see the value of m is 0. The value of m is 0 and n is greater than 0. Then this will result n plus 1. That means the value of second argument will increase by 1. Now, the value of second argument is 2. That's why it is increased by 1, and the whole function will give 3. The whole function will give 3. And in the similar manner, this is again the first case. This is again the first case. This is m is the value of m is 0 and the value of n is 1. Sorry, 3 greater than 0. So the resultant value will be n plus 1. That is 3 plus 1, that is 4. So here it is our answer. The value of 1 comma 2. These are the three conditions, and accordingly I have transferred the values of the function. In the first case, it has taken the third case. In the first case, it has taken the third condition, and in the second case, again the third condition, and in this case, it is taking the second condition, and after that, it is taking the first condition. These are three different conditions, and according to the condition will provide output. Okay, now some interesting facts regarding Ackermann function is Ackermann function are defined only for non-negative numbers, means the value of mn should be well defined. That means you can't take it in a decimal or minus. Okay, according to the conditions, you can't take them. The second thing is it is totally computable function, means you can solve it mechanically, means by taking a pen and a paper, you can solve it. Like an algorithm, you can solve it. By putting some values of m and n in non-negative numbers, you can solve it. So the second function is, it is a computable function. Non-computable, it is not a non-computable, it's totally computable function. But for the larger values, it will provide a very big answer, a very big result. The third fact is the Ackermann function is not a primitive recursive. Primitive recursive means like a function is doing simple 2 or 3 operations like addition, subtraction, or something like that. It is not going into deep, but it is not a primitive recursive because it is dividing the function into different parts, and again solving it. Like this function, it is dividing the whole function into 2 parts. Again, the function is divided into again 2 parts, again 2 parts. So it's not a primitive recursive. That means a simple function. It will be a bit complex in nature. And the last fact regarding Ackermann function is it is not a polynomial function. That means it will grow in a faster manner. Again, I'm repeating the statement. It will grow in a faster manner as polynomial in comparison to polynomial functions. So these are the few facts regarding Ackermann function. That is, it is non-negative number. It is totally computable function. It's not a primitive recursive, and it's not a polynomial function. Now, here it is the program for C program for Ackermann function. I've taken the three functions and let me give you, just give me a minute. I'll share you in a different manner. Now you can see on your screen a program, C program for Ackermann function. I have made a function Ackermann and taking two arguments m, n, both are integer in nature. Now, this is the first condition. As I have told you during the definition of a Ackermann function, if the value of m is 0, then it will return n plus 1. But in the second, here it is the second condition, that if the value of n is 0 but m is greater than 0, then it will provide this function. And this is the last condition. This is the last condition. And this function is called in the main function. In this program, I've taken two arguments from the user as per the requirement of my program. Now I will run this function. Now the value of m is 1 and n is 3. It is giving me the 5. Now do one thing, just take a pen and paper and solve it. This will definitely give you 5. Okay, so just give me a minute. This is the program for Ackermann function. This is the function and I'm calling, here it is. I'm calling in the second printf statement. Here it is, by taking two arguments from the user m and n. This is the requirement of our program. As in the starting, I have already told you that we will take two inputs. We will take two inputs from the user and it will give one output, one non-negative integer output. So here it is, my video for Ackermann function. Thank you.